Today's lesson is 1.4, writing equations and inequalities. All right, to start, we've got a couple definitions. The first one being blank is a mathematical sentence formed by placing an equals symbol in between two expressions, and that is obviously an equation. Right, equation has the root equa in it, which means equals, so that's a very clear indication that when you have an equal sign, it is an equation. The next one is blank is a mathematical sentence formed by placing these looking symbols in there between two expressions, and they are not equal signs, they are inequalities, meaning greater than or less than, greater than or equal to, less than or equal to. So inequality is when it's not equal, equation is when it is equal. And then lastly is a word I don't use too often, or a phrase rather. Blank is an equation or an inequality that contains an algebraic expression. That is what is called an open sentence. I would not get too hung up on that if you've never heard it before. It's not used too often, at least out of me or from me or many of the other Algebra 1 teachers here. All right, so we have a table here we want to fill out real quick. On the left-hand column, you have the symbol, the middle column, you have the meaning, and on the far right, you have the associated words. So the associated words, make sure you are able to familiarize yourself with these because these are what show up in word problems, and this is what gives kids problems when they are unsure of what the problem's asking because they don't know these associated words and they mean less than or they mean greater than or equal to. All right, so the first one, the first row is filled out for you, the equal symbol. Okay, it means equal to or the same value, and the associated word is the same as. The next symbol here, now I'm not going to go into a huge long rant as to why, but just trust me on this. And I know the table doesn't do it justice, but whenever you have an inequality of any kind, always read it from the variable. That will help you out tremendously. A lot of you guys have been lied to by saying you always shade to the left, you always shade to the right. That's going to be disproven here as we move on through the course. So always read these from the variable. So in this case, x is less than 2. So your meaning is obviously less than, and fewer than is your associated word for that symbol. This next one says x is greater than 2. The alligator does always eat the bigger value if you're still unsure with that. X is greater than 2, so this is obviously the meaning is greater than. And the associated word here is more than. Moving along, x is less than, and when it has a line underneath it is less than or equal to 2. So your meaning here is less than or equal. Your associated words are at most or no more than. These are the tough ones. At most, meaning it cannot exceed that value, but it could be that value. So in this example, 3 would not work for x. That's too big. At most it can be is 2. The solution to this could be 1.999999 forever. The solution could be 2, it could be 0, it could be -5. Those are all less than or equal to 2. Anything above 2 is no good. And the same thing is true here. You have x is greater than or equal to 2. So greater than or equal to, well, I guess not 2 because we want the generic, but greater than or equal to. And then your keywords or associated words here are at least and no less than. Again, it can be the value of 2, but in this case, it has to be 2 or anything bigger than 2, okay? All right, we have 3 examples here, but first I want to note that you can combine inequalities. This is called a compound inequality, and we'll spend a good unit on this here later this fall. Sometimes 2 inequalities can be combined. For example, if you know that x is bigger than 4, but x is also less than 9, you can combine them to form this compound inequality that is read x is greater than 4 and less than 9. So x is strictly between, it's a bound. You'll learn about that in calculus. X is bounded by 4 and 9. Okay, it cannot be 4 and it cannot be 9, but it can be any number in between those two. All right, so these couple of examples, we need to write out what they're saying algebraically. So the first one says the difference of twice a number k and 8 is 12. So the difference of twice a number k, well, twice a number is 2 times k. And difference means subtract. So the difference between twice a number k and 8 is, or is equal to, 12. Your second example says the product of 6 and a number n is at least 24. So let's take care of the easy part first. The product of 6 and a number n. Product means multiplication. So the product of 6 times n is at least 24. So when you say at least, it could be 24, it could be 25, it could be 26, it could be 100. It has to be at a minimum 24. At least includes the value. It could be 24 at the very minimum, but it must be also greater than 24. So that's why it is a less than or equal to symbol there. Okay? Your last example here, a number y is no less than 5 and no more than 13. Well, the red flag here is you have two numbers, you have no operation, you have no phrasing in there indicating you need to add, subtract, multiply, or divide. That's a red flag right there. All you know is a number is no less than 5 and no more than 13. Well, that tells me that I'm kind of bounded between 5 and 13. Y is somewhere in the middle of it. So if I erase this part first and ignore the 13 there, let's focus just on the relationship between y and 5. It says a number y is no less than 5. No less. Okay? So it could be 5, but it certainly is not 4, 3, 2, or 0 or anything else. It must be either 5 or bigger. Now let's focus only on the relationship with y and 13. It cannot exceed 13, but it could be 13. It says no more than 13. So then y is greater than or equal to 13. So that's how you write those three out. These are, obviously they're starting to get a little bit more complex, but hopefully it's nothing too much. But if you have any questions, please email me and we can get this all straightened out. All right. This definition I took out of the book. I'll give you the book's definition and I'll tell you a better way to describe it. Nevertheless, blank is when you substitute a number for a variable in an open sentence such that x plus 2 equals 5 or 2y is bigger than 6. The word here is solution. And I think a better definition is it makes the statement true. For example, for this statement to be true, the only number that would make x plus 2 equal to 5 would be 3. Okay, so 3 would be a solution because when I substitute 3 in for x, I get a true statement. So I kind of like my definition a little bit better than the textbooks. Now, for these next 4 in this table, we need to check to see if 3 is a solution for all of these. So when you check to see something is a solution, you've heard your teacher say this 1,000 times, you plug your answer back in to make sure it's true. That's what a solution is. This is kind of validating and proving that you got this equation or inequality correct. So in this first example, 8 minus 2x equals 2. I need to see if 3 is a solution to this. So 8 minus 2, but I'm not going to put x in. I'm going to substitute 3 in for x. When I do that, I get 8 minus 6 equals 2. Well, 8 minus 6 is 2. You get a statement that is true. 2 equals 2. Therefore, yes, this is a solution. 4x minus 5 equals 6. Well, 4, I'm going to replace the x with a 3, minus 5. is equal to 6. Let's see if that's true. 4 times 3 is 12 minus 5. Does that equal 6? Well, 12 minus 5, I think, is 7. And 7 does not equal 6. Therefore, this is not a solution. I got a false statement. 7 does not equal 6. That is a false statement. Okay? Your next one. 2z plus 5 has to be greater than 12 when z is 3. So replace z with 3 plus 5 greater than 12. So 2 times 3 is 6 plus 5 has to be greater than 12. Well, I think we would all agree that 6 plus 5 is 11, and 11 is not greater than 12. Therefore, 11 is not, and when you put a line through an inequality or an equal sign, that means not, like 11 is not greater than 12. So you know it's not a solution. All right, finally, your last one, 5 plus 3 times 3 less than or equal to 20. So 5 plus 3 times 3 is 9. Has to be less than 20. 5 plus 9 is 14. This is a true statement. 14 is less than or equal to 20. So this is true. Therefore, it is a solution. So again, whenever you're checking a solution, you're going to substitute whatever you think the solution is into the original equation, and you need to see if you get a true conclusion or a false conclusion. If it's a true conclusion, the statement that is a solution. If it's a false statement, that is not a solution to the equation or inequality. Okay, on your own, take a couple minutes. So this is one where you will have to pause on your own and take a shot at these. All three examples, A, B, and C, are saying is 5, the number that's outside a solution here. Is 7 a solution here? Is 9 a solution here? So take a minute, try those, and then hit play when you're ready, and we will go over them. All right, hopefully you've paused it and you got them all right, but let's check our work. For A, is 5 a solution to 9 minus x equals 4? 9 minus 5 equals 4. When you subtract this, you get 4 equals 4. Yes, that is a solution. Moving on, B. 7 is my proposed solution. 7 plus 5 must be less than 15. Well, this comes out to be 12. 12 is less than 15. Again, it checks out. Yes, that's a true statement. 12 is less than 15. Therefore, 7 is a solution to this inequality. Lastly, take your 9, plug it in. 2 times 9 plus 3 is greater than or equal to 21. Okay, well, this comes out to be 18 plus 3 greater than or equal to 21. 18 plus 3 is 21. So the last thing I find here is 21 is greater than or equal to 21. This is true. If you had only written if you only had this symbol, it would be a false statement. But because it is greater than or equal to, this is, yes, a solution. Okay? So hopefully you got all of those right. All right, 2 word problems, and then you're done. Your first one says, the last time you and 3 friends went to a mountain bike park, you had a coupon for $10 off and paid $17 for 4 tickets. If you pay the regular price this time and share it equally, how much does each person pay? All right, so several things we got to figure out here. First thing we need to figure out is, how much is it for full price? Well, if you go discounted, it was $17, but that was with a $10 off coupon. So we're going to add to that $10 and see that the original cost to go to this park is $27 because 17 plus 10 is 27. So that's my full non-discounted price. Now, this is the second time that this textbook has tried to sneak this into you. The last time you and 3 friends, so it's not 3, it's 4 total people, you and 3 friends. So they like to subtly kind of just slide those in there as a little extra step you got to pay attention to. So I'm going to take 27 because that's the total amount of money spent to get into the park. And the question's asking, if you pay regular price this time and share equally, how much does each person pay? Well, you have $27. There are 4 of you total. When you divide your 27 by 4, you get $6.75. So that's what each one of you will pay full price to get into that park. All right, your last question. I think this is a really good question because this is applicable to a lot of things, not just points per game in basketball. So a basketball player scored 351 points last year. If a player plays 18 games this year, will an average of 20 points per game be enough to beat last year's total? So we're going to come back to the word beat here because that's going to be a big way or a big clue as to what inequality do I use. And obviously it's not going to be an equal sign, but we'll address that here in a minute. So the first thing I'm going to do is I'm going to say, all right, I'm going to let P equal points per game. So I just picked P because it starts with points. So points per game will be denoted by P. So if a player plays 18 games, so 18 times P, and we know that the total it has to beat is 351. Now the inequality symbol that must go here, I want to beat that score. So it's not going to be a greater than or equal to, because if I get 351 points in my second season, I didn't beat my total from last year, I tied it, right? Beating and tying are two different things. If I want to beat the score, I got to do, 351 is not going to beat it. It's got to be 352 or higher. So my inequality symbol is strictly 18P is strictly greater than 351. Okay, so now to figure this out, they're asking me, will 20 points per game be enough to beat last year's score? Well, I don't know. Let's find out. Let's take our 18, multiply it by what I think my average point per game will be, which is 20. So 18 times my 20 points per game average, does that beat, not 350, 351? Okay, well, in your calculator, if you type in 18 times 20, you're going to get 360. And last time I checked, that is a true statement. So 20 points per game will be enough. Okay, check Google Classroom, see what you have due, what assignment you have. If you guys have any questions, please shoot me an email and I'll get back to you as soon as I can. If not, I will see you in class.